Hey everyone, it's UV here with the second tutorial about the 2D particle system using only tubes. In this tutorial, we will end up with uh, this thing here. Um, Basically, we are taking the system that we built in the first tutorial and adding instead of the vector field, we're adding attractors. Um, so if you didn't saw the first tutorial, I will link it down in the description, and I highly recommend to watch it before you continue with this tutorial. So um, there's a lot of stuff that you can make with these attractors. For example, just make it instead of attract ripples, and you have like this look, and a lot of other stuff that I will try to show you, and I encourage you also to play with it and to try to build and manipulate those points by yourself. So let's do a quick brief about the system from the other tutorial. So I have added this post effect over here, and you can look at it and see what I've done. It's just like to make the final look much more nicer. I've added like a luma blur with this kind of ramp that will basically blur the edges, which makes it I don't know, nicer, I guess. um, and a bunch of other stuff, but I want to focus on actually creating the attractors. So let's quickly see what we have here. We build the initial position in the first tutorial, and it's just like a grid of points. I've added a small amount of noise here to uh, start them, like as you can see, like just a bit randomly. um, Makes it much more nicer in a lot of times. In this case, it actually doesn't really matter. let's uh, let's leave it for now. um, then we build the life of the particles. Essentially what we did is we generated random numbers, and then decrease them in each frame uh, in a small amount, and when they get uh, um, below the zero, we initializing them to the initial value, and that way we have like a life to each particle that is decreasing, and then he dies, and then he uh, reborn in his initial position. After that, we build this vector field that we can see if I drag it to the select here. So using only like two noises, we generated this vector field, and then we multiplied it by a small amount of like a small number to basically add in each frame we add like a small amount of number to the position of the particles. Without it, it's just going to explode, as you see. Um, and then we and this green section, it's the attractors that we will build today. And then we ended up doing the compute feedback loop that basically takes the position, the initial position, and in each frame in the feedback loop it's adding the vector field from here. Before adding it, we remapped it to the new position of the particles, because if we don't do it, it's just going to be like this, and it won't work properly. So this is like a very important thing to do. Generally, the TouchDesigner actually has, if you use noise, only noise in the to generate the vector field. So in the second input you have noise coordinate map. So it's like a building thing in the noise. So it's essentially it's like doing what we are doing here. It's like remapping the noise to different coordinates. So because now we're using only noise, I can actually um, grab a select and take the feedback, put it in the select. Let's turn on off the remap, take this select, which is basically our particles current positions, and put it into the second input of the second noise, which is like the last noise. And you see it's like the same thing, but this doesn't work well because if you don't use noise, for example, we're going to build like something else, the attractors. So the remap is much more general thing to do. But if you use only noise, so you can use this technique. So let's keep the remap here. Oh, actually, looks cool. We're remapping and twice here, so it's making this nice effect. So you've got a bonus here by mistake. But yeah, I think generally in TouchDesigner you sometimes do random stuff, and nice things happens. So yeah, but let's turn it off for now. Um, so what else before we continue with the attractors? I think, yeah, I've added like arc bow camera. So this is like the panel, okay, and I'm opening it in this tab. So you can actually grab the simulation and zoom in, zoom out, and if you press H, it will be fixed in the initial, in the default position. So it's, for me it's convenient. And okay, so I think we are ready to build the attractors. So let's delete this section. Okay. uh, Actually, before we do it, let's see what do I mean by the attractors. Okay, so what we're going to do essentially is to build this small instance in network, very simple, like circles with the noise that is this. It's like the position of the circles, and we're going to put a texture in each circle, and this texture, it's basically the vectors of the force of the attractor, which can be attracted or be repulsed. It depends if what we choose. And this texture is basically our new uh, vector field. We, of course, we blur it a bit because it's, you will see it will make it much more nicer. And also we as the same as we did for the vector field from the noise, we multiply it with a small amount of number, with a small value, uh, so in each frame it will attract by a small amount of number, and it won't like explode like I showed you before, like this. um, so yeah, let's start building this. So let's delete um, the whole section of the attractors, and actually let's put all the compute over here. Also, this is also a part of the attractor, so I will delete this also, and the geo also I will, oops, sorry, I will delete this. Cool. So now we are basically from the point that we ended up with the first tutorial, and let's start building the attractors. So I want to start by building only one attractor. Essentially, I want to build a force that will attract all the particles to the center of the panel. Okay, so actually let's reduce a bit the brightness here. Okay, so for that, what we need to do is to calculate the vectors that will attract all the particles to the center. So let's grab the initial position we have here, the initial position in this select. So let's copy it, put it down, and let's connect a constant, and we want only to set the resolution. So we want to this contract to have the position of the center of the grid of points. So it's located in 0.05 and 0.05. So let's change it. Right, and we want to subtract those two. Actually, we want to subtract this from this, and let's make this subtract only 32-bit RG, because we only use the R and the G. So what we have here is basically the direction of the force that will attract all of the particles to the center. So let's have a null over here, and we can call this guy attract force. So if I change here in this select, let's actually color it with black, okay, or maybe something more. Yeah, with this select we change instead of the vectors we put the attract force. So what happened is all the particles are being attracted to the center, um, and the force is it's very big, so we can actually put a math here and reduce it a bit. Sorry. Yeah, cool. So as you can see, it's all the particles are being attracted, and if we give it a negative number, they will move the opposite way. Um, so this is like a basic of an attractor, um, but what we aim to do is to have a lot of attractors in several positions that will move around, and only the particles that are um, inside the or like near the attractors will actually feel this force. So for that we're going to build this small instancing uh, circles. Um, First, what they did before, I've added three constants um, to the constant data operator. And what we need is, first we want to have the number of attractors, which will be now 10. For now let's change it to 1. We want to have the attractor size, which will be the size of the circles, uh, and the attractor amount, which will basically we can tweak it, and then it will be the amount of force that we're giving the attractor. So let's put it to 0.545. So these three we need to add them. Okay, I've already added them, so you go ahead and add them. So let's build the instancing, and we will grab noise. In the noise we need to, let's open this and make it smaller that we can reference all the parameters. So in the noise we want to have the number of attractors, and let's make it 32 RG and not monochrome, and grab a null, call it what, actors attractors pose. Okay, and let's have a geo and a camera and a render. Now in the render we want only the geo one, so let's just drag it to here, and we don't need any light In the comment tab, let's change the resolution to the count, which is the number of particles I use, 800, which is kind of a lot. So if you have if you don't have a strong GPU, so you might need to reduce it a bit. So try yourself to see how many particles your GPU can handle. I think 800 it's fine for the most of like GeForce stuff. Anyway, let's continue. We change the pixel format to 32-bit float RGBA, and yeah, that's it, I think. So let's have a null here and call it Attractors, and let's go inside the geo and delete the torus. Let's grab a circle. Oops. And a transform, and let's turn on the display and render, and in the transform let's reference the size, tractor's size. Cool. Let's go outside. Let's see if we have the circle. Yes. Great. In the camera, actually, let's change in the view. We don't need any perspective, so let's change it to orthographic, and yeah, and set the the ortho width to 1, and the ortho region to bottom left. Okay, so let's see if everything is okay here. Yeah, I think it's fine. Okay. So now what we can do is add a constant material, drag it into the geo, and basically what we can do is to take this texture, which is our force, and put it in the column map of the attractor. So yeah, we have this circle over here, but let's change the noise seed to something different that we can't actually see the circle. Something is not right. Wait a second. Oh yeah, I forgot to do the instancing part. So in the geo, go to the instancing tab and put the tractor position, and we need only R and G. So yeah, now we're good, and we have our circle with this force being in its texture. So if I put the attractors instead of the this attractor force, let's see what happens. So we see our circle over here. Let's reduce the brightness a bit, and we see like a black circle because the force is still very big, so we need to um, reduce it. But before we do it, what I want to do is to normalize all the vectors, all the points to be in the size of 1, and then it will be much more nice to work like this. So for that we will add a math top, and we will take the length and max the alpha here, and we only need 32 bit mono. And after this we add a composite, and add it like this, and change in the composite, changing the transform, change it to input 1. Yeah, sorry, this needs to be like this. Yeah, and the operation should be divide. So now we have like the same texture, but it's normalized. So it's much more nice to work like this. And from here what we can do is add math to control the amount of attraction. So we take the step here and multiply it by the attract amount. Okay, so as you can see, if I pulse it, it's actually attracting yeah. So now we can increase maybe the size and reduce a bit the amount of attraction, and slowly you can see that all the particles are being attracted. um, what else we can add here? It's a blur to make it more like smooth. So in the blur, let's change it to 21 and 4. Yeah, and we can change the size back to small and increase the amount of attractors. So we get this nice movement, and you can see these are attractors, and we can increase the attractor amount, something like this. Maybe make it a bit brighter. Yes. Okay, so a nice thing to do is to actually make the attractors move by animating the noise. maybe a bit slower. Yes, looks nice. Um, what else? What else we can do is um, we can basically grab the constant geon render and to have another render system, but instead of the color map of the force, we keep it white. And let's add a null here and select it and grab it to the instancing section, and from here we can add another blur and a level and a no, and this will be our color. So in the instancing tab number 2 we can put the color in the color and make it R and R, and actually in the render you can change it here to 32-bit mono, and now like only the the particles that are being attracted are being much more brighter. You can play with the blur and with the level to make it as you wish. So yeah, so particles that are not being attracted are less brighter than the particles that are being attracted, which gives it a nice look. And you can play with the post effect as you wish. Um, yeah, so this is it. And there's a lot of things that you can add and play with. Also, this amount of force, you can change it and also animate it if you want. Like for example, with a noise or something, the noise chop in the command, going on the time slice and just reference it. Um, let's yeah, doesn't really work for me, but yeah, anyway, you can think about your own stuff. You can also make it a repose force. What else you can do is to change in each tractor size. Let's copy this noise and tractor and change this attractor to tractors size, and in the noise we can change it here to 32-bit mono, um, and monochrome. And in this geo we go into the forest instancing tab and drop it in the scale. Also for the other geo. So now you have the attractors with different sizes, and you can also grab the noise here and put it uh, to the scale noise, uh, which will make it nice. Like the scale will spread out more randomly and nicely. Um, you can reduce here the just stop the animation of this noise. Yeah, just you know playing around. So it it doesn't look like attractors anymore, you know. It's like really something different, um, which really, I don't know, I like it very much because when I start building it I was like, yeah, let's build an attractor. This is like a common thing to do in particle system. But when you tweak and change the stuff, the scale and the position, and also add this color thing, you know, so it makes it really nice looking system. And so yeah, I hope you like it and you will play with it, and I really want to see stuff that you make with this system, because really I think there's a lot of potential to do nice stuff. You can add colors, of course, as you wish. So yeah, this file will be available in my Patreon. You can go there, and if you want, you can also support me. Um, and I think this is it. I hope to see you soon in another tutorial. Um, and I think slowly this system will grow, and uh, in the future I'm planning to also extend it to 3D, but I think there's a lot of stuff to do in the 2D section, and it will never end, you know. This software really is amazing. Yeah, so Have a nice day, and if you have any questions, feel free to contact me. Bye bye.